everyone! Today I'm honored to present to you my final year project, which is the face recognition and tracking using the drone, and which has been thoroughly supervised by Mr. Nunhuck. But first, allow me to introduce myself. I'm Ashiyaa Nunhuck. I'm a level 3 undergraduate student majoring in computer science in the Faculty of Information, Communication and Digital Technologies at the University of Mauritius. Now we will move on to the video content, which contains the aims and objectives of the project, the system architecture, the functionalities of the system, which comprises of creating and connecting to the database, checking an entry in the database, training of the dataset, the drone specification, face detection and recognition functionality demonstration, the tracking functionality demonstration, the output video saved by the system functionality demonstration, and the face distance measurement additional functionality demonstration, followed by the conclusion. Let's move on to the aims and objectives of the project. The aim of this project is to develop a facial recognition and tracking system that is to be used in an automated aerial vehicle known as a drone. Its focal point is streaming a video capture from the drone device to the local machine device connected by Wi-Fi. The drone has the ability to fly and detect, as well as recognize both known and unknown faces, as well as track a moving person from a distance. This drone-based facial recognition and tracking technology can thus be used as a surveillance medium in today's world and can be a potential tool against criminals. The expected objectives to be achieved in the fulfillment of this project are as follows. Understanding the concept of face recognition and tracking using algorithms. An in-depth examination of existing systems, tools and technologies. Appropriate prerequisite gathering and design for the system. Retrieval of multiple human images among other features from an input image or video for real-time face recognition. Training of the face data to be used for facial recognition. Streaming real-time video from drone to the local machine by Wi-Fi connection. Detected face comparison and matching from a database using the drone. Recognizing faces at different positions and distances from the drone's camera view. Tracking a single person from the drone's camera. Implementation of the system using the most suitable face detection, recognition and tracking frameworks. Demonstrating the three main aspects, which are multiple face detection, multiple face recognition using known and unknown faces, as well as tracking motion of the drone to follow a single person in an outdoor setting. Analysis of the face distance effect and position of the face of the person. System testing and evaluation. The system architecture represents different stages of the system design. It consists of the architecture for generating and training face data, the recognition stage, and the tracking stage. The system architecture diagram represents how generating and training the dataset works. The steps are broken down into the following. Firstly, the name and credentials are entered by the user. The data is saved in the SQLi3 database. The local machine's camera opens and the face detection functionality is applied onto the frame using the face classifiers. Samples of the user's face are taken and saved into a directory with a subdirectory named after the person and the sample's name concatenated with the person's name as well as their ID. Using deep learning, the face samples are encoded and the embeddings are saved in a pickle file. The system architecture diagram represents how face recognition works. The steps are broken down into the following. First, the drone is connected to the local machine through UDP connection. The drone takes off and the camera starts video streaming in real time. the face detection functionality is applied to detect people in view of the drone's camera. A counter is initialized to count the number of faces detected. For each detected face, features are extracted and compared to the encodings the pickle file. Matched and unmatched faces are generated. For each detected face, the counter is incremented. The frame displayed on the local machine either outputs the name of the recognized person or quote-unquote unknown near faces that are unrecognized. The number of faces detected from the drone's camera is also output. The system architecture diagram represents how face tracking works. The steps are broken down into the following. So, as previously stated, the drone is connected to the local machine and streams video in real time. After the recognition phase, the user can track any known person by using the double left-click mouse event onto the face of the desired person. On clicking, the face tracking functionality is applied. A PID controller is initiated for smooth drone tracking. Quote-unquote track is output on the frame showing that tracking is on. In order to stop tracking, the double right-click mouse event is applied onto the face. On pressing the Q key on the keyboard, the frame closes and the program stops. A connection is created using the sql.connect command to a database named people.db where all the credentials of a person is saved. The table face details is created with attributes ID, name, and age. Each name entered is attributed to the ID, which is auto-incremented. Now it is time to collect face data from people. I have used my own face in this demo. My credentials are added into the database. This process is carried out using Viola Jones' algorithm previously discussed, which makes use of her cascade classifier to detect faces. The laptop camera is opened and face detection bounding boxes appears on my face. About 20 samples of my face is retrieved and stored in a directory named people and subdirectory named after me in the format as shown. Ashiyaa is my name, followed by my ID, which is 1, followed by the sample number. Next, the data previously entered is checked if it has been saved correctly into the database. On running this line of code, all the rows in the database is shown. Since it exists only one record, the ID, the name as well as the age is displayed. The next step is training the dataset. As shown, there is no files into the encodings directory. The training dataset step is carried out using the deep learning approach implemented using the MDCNN detector FaceNet model traced on TensorFlow with Keras for feature extraction and softmax for classification. The trained face embeddings are stored as a .pkl file to be used for recognition. The DJI Teledrone is used since it is equipped with a rather high quality image processor and impressive hovering performance. Its camera features 5 megapixel photos and HD 720 videos at a maximum flight time of 13 minutes. It comes with a battery, a micro USB cable for charging, a set of propellers and propeller guards, It includes an integrated Wi-Fi module and also has its own SDK so that it can be programmed via text commands. We will now have a look at the face detection and recognition part. So firstly, the drone is connected to the local machine using UDP connection and Wi-Fi. After successful connection, we will now run the program. It takes about 20 seconds for processing the data. As soon as the program is successfully loaded on the drone and the drone takes off, the face detection functionality is loaded and faces in view of the drone's camera are detected. The face is compared to the face embeddings previously stored. If the face matches, the name and ID of the person is output to a frame visible on the local machine. If the face is unmatched, the face is labeled unknown on the frame. We will now have a look at a short demo on how the system works. The second part of the system consists of tracking a recognized person. This part of the project is implemented using the tracking by detection functionality, which is implemented using the face center and the face area as parameters to calculate the yaw velocity of the drone. A PID controller is used to keep maximum stability of the drone during the execution and to reduce error in its steady state. So, after the drone recognizes the faces, the face tracking functionality is applied in turn. The desired recognized face needs to be selected by double-clicking the mouse onto the frame, and the drone starts tracking the face by processing the person's ID. As seen, the drone successfully tracks the selected known face. During the execution of the drone, a video recorder records all action performed by the drone. After the program closes and successful recognition and tracking has been achieved, an output video is saved to be reviewed. The output video is demonstrated as such. The face distance measurement from the drone's camera has been included as an additional feature into the program to make it even more interesting. So, that was the video demo for my final year project, which is the face recognition and tracking using a drone. I hope that you enjoyed watching this video as much as I enjoyed working on this project. Finally, I would like to thank my supervisor, Mr. Asbiduman, for supporting me and for giving me the opportunity to work on this project. So thank you everyone for watching.